For any assignment-related queries, call us at +1 678 648 4277. You can mail us at 1,678,648 4277 support@solidworksinmenthelp.com support@solidworksinmenthelp.com or reach us at https://www.solidworksassignmenthelp.com. Moderately large deflection theory of beams. Problem 6-1. Part A. The Department of Highways and Public Works of the State of California is in the process of improving the design of bridge overpasses to meet earthquake safety criteria. As a highly paid consultant to the project, you were asked to evaluate its soundness. You rush back to your lecture notes, and you model the overpass as a simply supported beam of span L with an overhang A equals 0.01 L. Assume that the distributed load is a sinusoidal function. A. Calculate the maximum allowable midspan deflection, with the critical under which the beam will slide off its support. SolidWorksAssignmentHelp.com. Part B. Assume that the above design with an external axial force N equals 0 and has a safety factor of 1. The design of earthquake-resistant structures requires a safety factor of 5, meaning that W critical must be increased by a factor of 5 without the bridge collapsing. Two possible design modifications were proposed. In the first one, the overhang is simply increased to. In the second design, a tensile force N is applied to the bridge to increase its transverse stiffness and thus reduce the central deflection and the resulting motion of the support. B. For the first proposed modification, what length of the overhang will meet the requirement of a safety factor of 5? Give your result in terms of the original A and other parameters if needed. C. For the second design, what is the magnitude of the dimensionless tensile force N/EA that will give a safety factor equal to 5? D. Which design is better? Can you think of a third alternative design solution? Recall. SolidWorksAssignmentHelp.com. A. Calculate the max deflection under which the beam will slide off its support. Assume N equals 0. Since the applied load is a sin function, we can assume the deflected shape will also be a sine function. Substitute the above equation into equation 1. We have SolidWorksAssignmentHelp.com. Thus, the maximum allowable midspan deflection is. We're given. SolidWorksAssignmentHelp.com. B. Case 1 increase to meet safety factor of 5. Recall. SolidWorksAssignmentHelp.com. C. Case 2 apply a tensile force N. So now we want to calculate, and that will give us the equivalent effect of applying a safety factor of 5, in which case? In the case of SolidWorksAssignmentHelp.com. D. Which design is better? It is difficult to say which design is better. Each design has its advantage and disadvantages. For case 1, we will have a long overhang which may not be aesthetically pleasing. For case 2, it may be difficult to apply constantly a tensile force. Other options include a stiffer simply supported beam, or add cables to suspend the bridge. A long-span aerial tramway steel cable of length L equals 1 km is loaded by a hurricane wind with intensity Q, X, sinusoidally distributed between the end stations. The cable deflects by W equals 5 m. SolidWorksAssignmentHelp.com. A. Calculate the resulting load intensity QOB. Calculate the tension in the cable N. C. Calculate the tensile stress. D. Compare C with the yield stress and determine the safety factor using the equation of equilibrium. However, a cable has no bending stiffness, so our equation becomes NWQ. Integrate twice. SolidWorksAssignmentHelp.com. Plug in the boundary conditions to solve for the constants. A. Calculate the load intensity. The cable deflects by at the middle point XL/2. B. Calculate the tension on the cable N. Solidworks assignmenthelp.com. Solidworks assignmenthelp.com. C. Calculate the tension stress on the cable. D. Compare with the yield stress and determine the safety factor. Safety factor equals yield stress / working stress 300 / 12.95. Safety factor equals 23.17. Solidworks assignmenthelp.com. Problem 6-3. Plot the dimensionless deflections, W/L, versus the dimensionless line load for both bending and membrane, cable, solutions over a slender beam. At what dimensionless deflections will the bending and membrane solutions be equal, assuming a length to thickness ratio equal to 10? Problem 6-3 solution. Recall bending and membrane solutions, pure bending membrane. Solidworks assignmenthelp.com. Let's call. We want to plot bending y equals. Solidworks assignmenthelp.com. Membrane y equals. Use a length to thickness ratio equal to 10, L/H equals 10. Bending y equals 12.32x. Membrane 0.345. Solidworks assignmenthelp.com. At what dimensionless deflections will the bending and membrane solutions be equal? So at the bending and membrane solutions will be equal, where the dimensionless deflections. Solidworks assignmenthelp.com.